Right, so the main distribution panel schedule, we're going to enter the header information last, so we're not going to work on that right now. But what the main distribution panel schedule is, it's basically just showing us, we have the electricity coming in through the meter, and it comes into the main distribution panel first. And from the main distribution panel, I'll show you a line diagram here that shows that. So we have the electricity coming through the transformer. From the transformer, it goes through the meter. Then it goes into the feeder for the main distribution panel. From our main distribution panel, we now have 4 circuits that are split out to the individual panels that we'll need for this building. We're only worried about panel 3. That's the only panel that we have to worry about in our section or our project that we're doing, because we're only doing part of the building, right? That break line in the building tells us that there's more to the building. They're likely going to have panel 1 and 2 in different parts of that building. So there might be another floor, there might be another wing. That's going to have panel 1 and panel 2. They're going to be essentially the same. We don't need to worry about those. We're only concerned about panel 3, but we need to understand that it's first coming through our main distribution panel. So once we've sized panel 3, which is why that was the first thing that we did, we can now fill out the information for panel 3 and complete the feeder circuit as well as the breaker to the main distribution panel. And then we can also figure out what's going to be happening in the main distribution panel. So they're all a very similar process. But once we know what's happening with that, this panel here, we know that we have 175 amps. We know the size of the feeder wire that we require. And we know the size of the panel itself, the circuit breaker that needs to be used for that. We can enter that information into our single line diagram. We'll get to that in a bit, but let's focus on the main distribution panel for now. So main distribution panel, we're going to split it up very similar to the way we did with the regular panel. So circuits on the left-hand side of the panel are using odd numbers. Circuits on the right-hand side of the panel are using even numbers. So the first thing that you're going to do, let me flip over to the instructions here. First thing that we're going to do is we're going to enter in the circuit numbers on the left, 1 and 3, and on the right, 2 and 4. We're only going to need 4 circuits here, so we don't need to go any more than that. Even though there's 6 spaces for us, we only need 2 of the 4. And we're also going to enter in the description of each of those. So again, leaving the header information for last. So this is the header up here. We're going to fill that out last, but we're going to enter in the description here. So the first description is going to be panel LP1 in room number 20. So that's panel LP1 on circuit number 1. We did that for a reason, to keep it easy for us so we know exactly what's going on. This number here, number 2, circuit number 2 is going to be, guess what panel? LP2. Okay? Circuit number 3 is going to be the panel that we've been working with, and that's going to be LP3. So let me make a copy of this. And we'll just change this. This is LP3, and this is in room, in our part of the building, it's in room number 15. Okay, so now that's sort of what we're going to be focusing on, is LP3 at this point. Okay? So it tells you the positions for the above. So you're going to fill out the rest of the panel with the description. So at panel LP2 and just make up a room in room number 58. Doesn't matter. And then the number 4 is going to be a little bit different. That's where it's a bit odd. Number 4, if we go down here, that's actually going to be the motor control center for position number 4. So what we're going to put the description there is MCC in room number 14. So many of you, as you've been going through, have noticed that we actually have an extra panel in room 15 that we haven't really talked about yet. That's actually the motor control center. So the reason why we haven't talked about it is because we just recently learned what a motor control center is. And that, I'll show you what that one looks like. That's the main distribution panel. Room number 14 has a motor control center. Let me show you what that motor control center looks like on more of a completed version here. Okay, so this is the motor control center right here, and it feeds each of these motors. Okay, so that's something that you're going to have to draw in as well. I know you haven't done that yet. Don't worry about it. I'm not looking for it for the sheet E3. You can if you want. You can put it in sheet E3 if you want. But I'm not necessarily looking for it in sheet E3, but for your final, you want to make sure you include the motor control center and include just a little wire connected to each of these motors and just arbitrarily place them. It really doesn't matter where they go. It's going to be up to the client to determine where exactly they're going to be. And again, don't worry about the circuit numbers. Yours may be different than mine. But just the motor control center, and we'll do a little home run that points to the main distribution panel. Okay, motor control center, because we have 3 motors. There's 3 little boxes that we use. Right, so again, worry about that for sheets E1 and E4, that final submission. That's when you're going to include that information in there. Fairly straightforward, fairly easy. Okay, so we're going to fill out the rest of this now, so we'll go back to the instructions. So we need to figure out what size that we actually used for the different lines within this panel. So when we go to, for example, our panel, LP3 in room number 15, we need to tell it how many amps we have and how many pole breakers are we using in this for this particular situation. So what was the size of the breaker for LP3? Do you guys remember? It's 225, right? Sorry, I don't want you guys to answer because we're recording this, but 225 amps is a 3-pole breaker that we're going to be using for LP3. So we come over here and we simply edit this to 225 amps, 3-pole. That's it, done. Whatever you decide, whatever you determine for LP3, just copy it to the other 2 panels that are almost exactly the same, okay? We're not worried about exactly what's happening in these other rooms, but we're just going to copy that over. So LP1, LP2, and LP3 are all going to be the same. For the motor control center, that's going to be a little bit different. That motor control center is going to depend on your calculations. So when you complete the motor schedule, you're going to be doing a feeder calculation as well. That feeder calculation in the instructions will tell you, how many, what's the circuit breaker size, how many conductors, what's the size of those conductors, and the conduit that you need for that feeder. So again, when you look at that motor control center, you're designing the feeder for that motor control center that goes to the panel. That was one of the steps. That's situation number 2. Example number 2, and you're doing that for your check assignment calculation. So you're just going to input the values that you get from your check assignment into this panel. So you can input the breaker size, and it's a 3-pole breaker. Whatever you determine, whatever your calculations are for the motor control center, that's what you're going to put there. Once we have that information, let's go back to the instructions here. We're going to complete the header using the appropriate values. So we'll use 208 volts, 3-phase, 4-wire. So up in here, 208 volts, 3-phase, 4-wire. The feeder, now this is going to be the feeder that actually feeds all of these. So there's a calculation that we use there. So we're going to calculate the feeder size according to the total number of amps required for the main distribution panel. So we're going to sum all of the individual circuit amps found in this panel. So we look at LP3. LP3 is using 175 amps. We take 175, and because we're assuming that LP1 and LP2 are exactly the same, it's 175 plus 175 plus 175 plus whatever you determine for your motor control center. That'll be from your check calculation. So when we look at the motor schedule, this is going to be the amount of amps that you determine are going to be required for that feeder. So that would be sort of like the overload size of the amps for that feeder. You're going to add all those up, and then you're going to look in table number 2, and you're going to find an appropriate feeder size for that number of amps. So let's say, for example, we add up 175, 175, 175, and let's just imagine that our motor control center takes 100. I'm just using an example. It's 625 amps. So we're going to look in table number 2, and we're going to use a 1250 kilo circular mill American wire, kilo circular mill size wire. So if you look in the table number 2, that's capable of 645 amps. Okay, this is just an example. This is not actually going to be your value. 645 amps is the capability for a 1250 kilo circular mill. That's KCMIL. If you look in table number 2, top left-hand corner, you'll see size AWG, comma, KCMIL. That's actually short for kilo circular mills. Let's call it KCMIL. You're going to use 1250 KCMIL. So that's what you're going to put in the feeder. The location of the main distribution panel is in room 15. So you're going to enter room 15 in there for the location. The cable's going to enter again at the top. We'll just say top. And now for the busing, let's go back to our into here. We're going to enter the total bus bar size, which is equal to the panel size. So we have a feeder. That feeder is going to We're going to have to size the panel based on the same panel dimensions that that we had in this example here, the panel current rating. We're going to choose the available panels from this list here. So it might be 150, it might be 225. We're at 625. That example isn't in here. We're using a bad example. Is essentially what we're doing. Bad example, but you're going to choose your panel size based on the total amount of total feeder size. So if you have 625 amps for your feeder, you're going to choose a panel that's going to be larger than that. Okay, so whatever your amps happen to be for the entire panel, I think what you'll end up being is you'll end up being closer to 100. So 100, 200, 300, and then you're going to have your motor control center here. And that's going to, so you'll be, you might be, well, you'll be over that 225. Just going to choose a bus size for that. So looks like I'll have to get you guys more sizes depending on the actual values that we determine there. We'll get to that, and I'll give you guys some new panel sizes. But and then the mounting of that panel, that's the last thing. So we'll put in the bus size, and we're going to put in the panel size. So, and this one is surface mounted. So the mounting is surface. That's our main distribution panel.